Hello guys, welcome back. Now we are going to solve the problem elimination of a ring which has come in binary round 1. So what is given in this question? We are given a cyclic sequence of size n. What the cyclic means that first and last elements are adjacent to each other. That is Sn is adjacent to S1. So this cyclic sequence has been represented in the form of a ring, and you can think that this ring is a magical ring. So if so, what is given? The ring itself hits equal adjacent elements. That the ring will not like if the two adjacent elements are equal. So if the two adjacent elements become equal, so the ring will erase one of the elements immediately. That is, so if two adjacent elements in the sequence are equal at any time, one of them will be erased immediately by the ring. The sequence doesn't contain equal adjacent elements initially. Initially, we are given a sequence such that no two adjacent elements are equal. So we can perform some operation in this sequence. So what is the operation? We can choose any element from it and erase from the sequence. For example, in this is the sequence 1 to 4, 2 3 2. If we erase element 4, so now this element 2 and 2 become equal. This 2 and 2 are adjacent to each other and are equal because 4 is erased. So the ring itself erase this element 2 that is given. If we erases element 4, then the ring would erase one of the elements equal to 2. The ring would erase either this or this element 2. Then the sequence will become 1 2 3 2. So what we have to find? What is the maximum number of operations we can perform? What is the maximum number of operations we can perform on this ring until the size the size of the sequence becomes 0 or the sequence become empty. Note, here is a note that if a ring is of size 1, then if there is only one element in the sequence, then it is it will not consider adjacent to itself, because it is given that Sn is adjacent to S1, that first and last element is adjacent. So if there is only one element, it will not consider adjacent to itself, so it will not be immediately raised, so that we can perform so that we can perform a operation on this element. Indeed. So we so what is the given in this question? In this question, we are given a single integer t, the number of test cases, and the the size of the array or the size of the sequence, and we are given n elements of the sequence. Here it is guaranteed that initially no two adjacent elements are equal, and what is given? It is guaranteed this. For each test case, we have to output the maximum number of operations we can perform. That is, in one operation, we can choose an element A and erase from the sequence. Okay, now let's take an example. So let's take an example. We choose a new whiteboard. So let's take there is only one element in the sequence. So how many operations we can perform? We can perform one operation individually on this element, and this will be erased from the this element will be erased from the sequence, and sequence will be empty. So the answer will be 1. Okay, if there is one element, then the answer will be 1. Now let's take another example. 1 2 1 2 3 and 1 2 3. No two adjacent elements are equal. So let's take, so what we can do here, we have to choose, we have to optimally erase elements. Now first we will erase this element 3. We will erase this element 3. Now these two elements become adjacent, 2 and 1, but they are not equal, so they will be not erased by the ring. Now we can erase this element 1. So 3 and 2 will not become adjacent. So we can erase this element 1, and 3 and 2 are not adjacent. Now we can erase this element 2, and 3 and 1 are not adjacent. Now we can erase this element 2, this element 1, and this element 3, and this element 1, and this element 3. So what you can observe here, we will erase one by one all the elements, and so in this case answer will be n. Answer will be the size of the array. Answer will be the size of the array. And if, for example, now let's take another example, 1 2 3 4 and 3. Okay, this is the example. So now what we can do, we can first erase this element 3. First we will erase this element 3, then 4, then 3, and 2, and then 1. So answer in this case is also n. Now let's take another example, 1 2 1 2 and 1 2. This test case 1 2 and 1 2. So now if we erase this element 2, for example, if we erase any of the elements, now if we erase this element 2, this 1 and 1 become adjacent. So the ring itself will erase this element 1. Okay. Now if we erase this element 1, now if we erase this element 1, okay, now we erase this element 1, and this 2 and this 2 become adjacent, so the ring will automatically erase this element. Now if we erase this element 1, these two elements are become adjacent and these are equal, so the ring will erase these elements. And now these two elements can be erased individually. Okay, so how many operations are here? So how many operations we can perform here? Here we can perform, as you can see, that for these number of elements, we can perform n minus 2, because these are n minus 2 elements. Two elements are here, and these are n minus 2 by 2 operations. Because if we erase one element, then the other will become adjacent to someone, so it will be erased by the ring itself. N minus 2 and 2 operations we can perform individually for these two elements. Okay, so here you have to observe a pattern, that if we have k unique elements in the array, k unique elements k unique elements. So here we have to observe that if k is greater than 2, means that if the number of unique elements in the array, in the sequence, is greater than 2, so we will find a way such that we will perform n operations. We will always find a way such that we can perform n operations. So if k is greater than 2, k is what? Unique elements in the array. So we can perform an operation. And if k equal 1, means there is only one element. If k equal 1, then we can perform only one operation. And if k is 2, means there are only two distinct elements, such that in this case, if k equal 2, then the answer will be this 2 plus n minus 2 by 2, because 2 for these two elements individually, and we can perform n minus 2 by 2. We can perform half of the operations for these elements, and these elements are how much? N minus 2. So n minus 2 by 2 and 2 operations for these elements. So we have to observe this only, that if the number of unique elements in the sequence exceeds 2, then the elements, then the operations we can perform are n. We will always find a way so that let's take another example, 1 2 1 3 into 1 3 1 3 and 2. Let's take this. So how we can perform the operations. First we can delete this 3, 1 and 2 are not equal. So now what we can do, we can delete this one, these are no, and 3 and 2 are not equal, we can delete this. 3 and 1 are not equal, we can delete this, then we can delete one by one individually. So as you can see, we have found a way in this that we can perform an operation. So this is the logic or the observations, a simple observation in this. So let's see the code here. So what we have done, we have taken the n input and the array. We have taken the input array, and then we will put all the elements in the set. So as you know, in the set the set will contain only unique elements. If the two elements which are if the two if we will if we try to put another element which is same, the set will not contain it. The set will contain only unique elements. So we put all the elements in the set of, so as dot insert of I, and if the set size is greater than 2, then we will output n, which means that we can perform n operations. And if shift size equal to 2, then we can perform n minus 2 by 2 plus 2 operations. And if the set size is 1, we can perform one operation. This is a simple code. Thank you guys. I hope that you have understood the code and the solution and the approach. So okay guys, thank you and bye bye. And if you have any doubt, feel free to ask in the comment section. And if you like the video, please like it and subscribe the channel. Okay guys, thank you, bye bye, and take care.